Hello, welcome to our video lecture series on chapter 6.1 in the Lock 5 textbook. And in the last video, we finished looking at baseball home field advantage, going through a complete hypothesis test, and we ended up with a p-value of very close to 0. As a quick reminder, if you're using StatKey or any other normal calculator and you get something like this, e to the minus 7, that's basically 0, statistically 0. And then we reject the null hypothesis if p's value is that low. Okay, so what I want to do, this last video, is go through the steps of the hypothesis test for one more test. Excuse me, here we go. This is a summary of what we did in the last video. Is to go through NFL overtime. Let's look at the start of the overtime in the NFL League. A coin is flipped to determine which team will kick off and which will receive. Question of interest is how much advantage, if any, is given to the team that wins the coin flip at the start of the sudden death overtime period. Those of you that follow football might know that this rule changed a couple years ago. So a couple years ago, they got rid of the sudden death overtime period. So we're looking at the time before that, when the first team to score in overtime won the game. So we're going to look at overtime's games played between 1974 and 2009. So a big time period. But unlike the last example of baseball, football only has 16 games a year. So we only have 428 games, which is still a pretty large, big sample size. The winner of the coin flip won 240 of those 428 times. And we're going to assume that overtime games playing during this time period can be viewed as a sample of all possible overtime games. So we're going to take this to be our sample proportion. And does this data provide sufficient evidence to conclude that the team winning the coin flip has an advantage in overtime games? And we're going to use a 1% significance level. All right, I copied this information over to a document. So I want to go back and forth and refer to the steps. I want to go through these steps of the hypothesis test. So one is state the null alternative hypothesis using proper notation. I will go over that and then describe what the population parameter represents. All right, so we can go in either order. I'm going to let P be the proportion of games won in overtime by the team that won the coin flip. So there's overtime and there's a coin flip to see who gets to pick whether they get the ball or not. So we're going to let P be the proportion of games won overtime by the team that won the coin flip. All right, then let's write our hypotheses in terms of this. And we want to know if evidence that has an advantage in overtime games. So if we assume there's really no advantage, we're going to assume this P to be 0.5. Equally likely that each team could win, whether you win the coin flip or not. And just like in the previous example, if there is an advantage, this should probably be bigger than 0.5. I'm going to put a question mark here for right now, because what is our sample statistic? The notation is p hat, and that's 240 out of 428. And if you throw that in a calculator, we get that to be about 0.561. So that makes sense. The evidence does support the alternative hypothesis. So this is reasonable to say that. The question really is, for statistical purposes, is it enough of an advantage to say that there is an overtime coin flip winning advantage in general, not just in these 428 games. So we've got part 3 on here. We've got the sample statistic. Now the standardized test statistic. Go back up here. That standardized test statistic. Actually, I'll put my slides. right here. So this right here is my formula for standardized test statistic, p hat minus the null value, and then divided by the square root of the null value times 1 minus the null value over the sample size. So I'm going to use this in my standardized test statistic formula. Standardized test statistic is z equals, and it's p hat. I'm going to write 240 over 428 minus 0.50, and then divided by the square root of 0.5 times 1 minus 0.5, all divided by the sample size n, and n is 428. All right, so I'm going to throw this in my calculator, and what I'm going to do is I'm going to keep as many decimals as possible. It's a graphing calculator, online calculator. I'm going to keep that 240 over 428 minus 0.5. And here I get in this top 0.6074766. It keeps going. And the denominator, I have the square root of 0.5 times 1 minus 0.5 divided by 428. And then I get to be 0.0241684 and so on. And keeping as many decimals as possible, I end up with 2.5135. And if we're going to 3 decimals, 2.514. We want 3 decimals as our standardized test statistic. I want to confirm the requirements are met to use a normal distribution. So successes is NP, which in this case we have 428 times n and 0.5. That'll be 214. And failures, those are teams that lost, would be n times 1 minus p. And that would still be 428 times 1 minus 0.5, which would be the same value. So these are both at least 10, so we can use normal distribution. All right, so I've got my observed statistic, sample statistic, standardized test statistic. We could use the normal distribution because we have a big enough sample size with the proportion. Now I want to calculate p-value and make a decision. So to calculate p-value, I'm going to go to stat key. Again, we're going to click the normal distribution. We're looking at, in this case, a right tail test because the alternative is greater than. So in stat key, right tail, and I'm going to enter that 2.514. The cutoff is the standardized test statistic, and then here we get a p-value of 0.006. So using normal distribution, p-value is 0.006. And that is less than, we're using a 1% significance level. 0.006 is less than 1, so we reject the null hypothesis. So I've got my p-value and decision, and then I'm going to ask you to write a concluding sentence talking about the evidence for or against the alternative hypothesis. The sample provides strong evidence that the alternative is correct. Going back to the beginning, that means the proportion of games won over time by a team that won the coin flip is greater than 50%. That the team that wins the overtime in the NFL does have an advantage. Up in parentheses, wins more than 50% of the time. And that would be our concluding sentence. This, again, something that's I would want, say a student who hasn't taken stats yet would be able to at least get your conclusion. Evidence that it does seem to help to win the coin flip in overtime in the NFL. Okay. All right, the last thing I wanted to mention, that's the ends the slides for chapter 6. I posted on Canvas, this over here, a formula sheet for chapter 6, because there's a ton of formulas. I don't care if you memorize them. So I will pass this out in class if I haven't done so already. I'll print one out for you guys. So here we've got standard error, confidence interval, test statistic. We'll go over this in class if we haven't done so yet. But this first column is all the formulas for a single proportion, standard error, confidence interval, test statistic. We're going to go through the rest of these in chapter 6. On the second page, we have the requirements or the assumptions necessary. So we have single proportion right here, and that's so we need to have at least the 10 successes and 10 failures. And then I put at the very bottom, sample size necessary. So in chapter 6.1, we went over this sample size. So I encourage you as you go over homework, quizzes, or anything, to have this sheet handy, whether you print it out or have the PDF open.